తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని. టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు, 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని అండ్ సరిత. టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత. మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 డిఎస్సి ఎస్జిటిలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్. స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్లో టీజీటీ మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, టీజీటీ బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, టీజీటీ సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, టీజీటీ సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, టీజీటీ తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, టీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, పీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, పీజీటీ ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 డిఎస్సి గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. డిఎస్సి గురుకుల టీచర్స్ మరియు గ్రూప్స్ ఎస్ఐ కానిస్టేబుల్స్ కోచింగ్ కొరకు డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422, 8885555202, 88585900, 8008954440, 8008954448, 8520844463.
Good evening to one and all. So today we'll discuss the syllabus, the mathematics syllabus for JL. So it is the same syllabus for it is general JL as well as Gurukula JL, right? So for general JLs we have 150 questions, right? So each question carries 2 marks. Totally we have 150 into 2, so we have 300 marks in general JL, right? Whereas in Gurukula JL, so we have 100 questions. We have 100 questions. Each question carries 1 mark. So totally we have 100 marks. Okay, but so the difference is in Gurukula JL we have negative marking, but in general JL we don't have any negative marking, right? So this is about the syllabus. This is about the marks distribution, right? So in the Gurukula JL as well as in general JL, right? So 300 marks in general JL, so 100 marks in Gurukula JL, but so the difference is we have the negative marking in Gurukula JL, but we don't have any negative marking in general JL, right? So please remember this, right? It is a very key important. So there is no negative marking in general JL, right? So there is a negative marking in Gurukula JL. So we have 100 questions, 100 marks in Gurukula JL. So in general JL we have 150 questions. Each question carries 2 marks. Totally we have 300 marks for subject. Okay. So please remember all these things. So we have, so in the mathematics, so we have the 11 topics for JL. So we have the 11 topics for junior lecturer exam. So the first topic is real analysis, right? The first topic is real analysis. The second topic is matrix spaces, right? Real analysis, matrix spaces are the same, comes under only one category, that is analysis only, right? That is only comes under only one category, that is real analysis only, right? Because the matrix space is also is included in real analysis only, but it is given separately, right? This is a given separate topic here, right? So what are the topics, what are the sub topics are there in the analysis? So please read all these things, right? So we have finite sets, so countable sets, uncountable sets, okay? So we have finite sets, countable sets, uncountable sets, real number system R. So in the real number system R, nothing but, so we have to define what is neighborhood, what is interior point, what is exterior point, what is open set, what is closed set, what is adherent point, so what is bounded, what is bounded above, what is bounded below, what is the infimum, what is the supremum, all these things are comes under this real number system, right? This real number system. So next, infimum and supremum of a subset of R, right? So these are taking from bounded conditions, okay? If you define the bounded condition, you can define what is infimum, what is the supremum, right? So next, Bolzano-Weierstrass theorem. So already you know that, I think you are very familiar with the statement of what is the Bolzano-Weierstrass theorem, right? So next, sequences. So sequence, the given sequence is divergent or convergent, so you need to check all these things, right? So next, limit superior and limit inferior of a sequence, okay? So these are the topics, okay, in sequences. And coming to the subsequences, what is subsequence and what is Heine-Borel theorem? So what is the statement of Heine-Borel theorem, right? So and infinite series. So see here, sequence is different, infinite series is different. Sequence is different, series is different, right? So the problems on series, how to already know that. So test of convergence, right? You have studied test of convergence. So we have studied many tests, right? So what are the tests we have included? So limit comparison test, P series test, okay, Rabbis test, root test, nth root test, logarithm test, etc., right? So we have many tests to check the convergence of the series, to check the convergence of the infinite series, right? So later we will discuss what is continuity, what is differentiability, what is uniform continuity. So continuity you can define on particular variable, and continuity you can define on interval also, right? The same thing. So we have to define for differentiability. So differentiability at particular point and differentiability on interval, and also you have to define uniform continuity also. So define at particular point and define at interval, right? So these are the different topics. So continuity, differentiability, uniform continuity of a real valued function of a real variable, right? So monotonic functions. So monotonic functions nothing but already you know that. So monotonic increasing function, monotonic decreasing function. So monotonic functions are convergent or divergent, right? So you can define all these things, right? So you can read all these things. So all the topics in monotonic functions also, right? So you can concentrate on all these topics, right? And also as well, so we have another topic, functions of bounded variation, okay? So next, differentiability, mean value theorems, right? Already you know that functions of single variables, we have many mean value theorems. So we have 5 mean value theorems. So Rolle's mean value theorem, Lagrange's mean value theorem, Cauchy's mean value theorem, Taylor's mean value theorem, Maclaurin's theorem, right? So you can define mean value theorems, right? So next, already you know that, I think you studied Riemann integrability. So in the Riemann integrability, so next we have many topics in Riemann integrability. So we have many theorems. So please prepare all these properties in the Riemann integrability, okay? So and also sequences, series of functions, right? Here sequences and series are defining on real valued functions, right, of a real variable. Here the sequences, series of functions, right? Here series sequences are given in terms of functions, right? So these are the topics, so in real analysis. So please read carefully. So each and every topic is very important in real analysis. Please concentrate on each and every topic, okay? So to do problems in real analysis in the JL exam, right? So we have the another topic is to the metric spaces, right? So this metric space is also comes under real analysis only, but it is given separately, so no problem. So we have the topics. So definition of what is the metric space, what is the completeness, what is the compactness, what is the connectedness. So these are the definitions. You have to remember all these the examples for metric space, completeness, compactness, connectedness, right? So please read all the properties in these topics, and also continuity and uniform continuity of a function from one metric space into another, right? So topological spaces, bases, subspaces, continuous functions, right? So these are the topics in metric spaces. So please read carefully right? Please read all the properties, all the theorem statements, right? So carefully, so to do problems in JL, right? To do problems in these topics in JL exam, right? So you can expect I can give you a weightage by previous papers, okay, based on our knowledge, right? So as per the previous knowledge, right? As per the exams we have already seen. So we have seen many exams, right? For JL, DL, like that, right? Okay. So based on that, so I can give you weightage of these two topics, right? I am combinedly giving the weightage. Okay, I am combinedly giving the weightage of these two topics. So I can give the weightage of these two topics 25 to 30 questions, right? So you can expect 25 to 30 questions from these two topics. You can expect 25 to 30 questions from these two topics. So these are the topics are very important. So if you are thorough in these two topics, if you are thorough in these two topics, you can score more than 50 marks. You can score more than 50 marks because so 25 to 30 questions. Each question carries 2 marks, so that you can get more than 50 marks from if you are thorough in these two topics, right? So please remember this. So we can expect 25 to 30 questions, right? Based on the previous knowledge, so we are giving the weightage of marks, right? Weightage of the questions in these two topics, right? Coming to the next, so we have the third topic is elementary number theory, the fourth is group theory, 5 is ring theory. So these three topics are comes under modern abstract algebra, right? These three topics are comes under modern abstract algebra. So we can give weightage of these three topics, right? I am giving weightage of these three topics. I can give the weightage 30 to 35 questions. You can expect 30 to 35 questions from abstract algebra, right? You can expect 30 to 35 questions from abstract algebra. So abstract algebra includes elementary number theory, group theory, ring theory, right? So if you are thorough in these three topics, you can get more than 60 marks. You can get more than 60 marks from these three topics. You can score more than 60 marks, right? You can score more than 60 marks in these three topics, right? So if you are thorough in modern abstract algebra, you can get more than 60 marks, right? So individually I can give marks weightage, but no need to give individually. So we have three topics are comes under modern algebra only, right? So modern algebra, modern abstract algebra, so that I can give weightage in single weightage. So that is 30 to 35 questions will come from these three topics, right? So just we'll see what are the topics in elementary number theory, what are the topics in group theory, what are the topics in ring theory. So just we'll see, right? So in elementary number theory, so we have the concepts, what is prime number, what is composite number, right? If you know what is prime number, what is composite number, you can go with next topics, right, in the number theory. So already you know that fundamental theorem of arithmetic. So what is the fundamental of arithmetic? So every natural number can be uniquely expressed as prime factors, right? So it is very important theorem to do problems in number theory, right? Each and every time we will always convert into prime factors, right? For any problem, okay, in number theory, so most of time we always converting into prime factors, right? So whatever the number will be given, we need to convert into prime factors. Later we will find out the solution in number theory. So it is very important theorem. Next, what are the divisibility conditions? So I think you are very familiar with the divisibility condition. Divisibility condition for 2, 3, 4, 5, so on, right? So you have to read all these things, right? So next, congruences. Congruences, you can define what is the definition of congruence, what is the importance of congruence, right? How to find out solution for congruence. Already you know that A is congruence to B modulo n, then n divides A minus B, right? N divides A minus B, or n divides B minus also, right? So this is the definition of congruence modulo. So we can find out solution for linear congruent equation, how to find out solution for linear congruent equation, how to find out solution for system of linear congruent equations, and how to find out solution for system of linear congruent equations with prime powers. Okay, so and also already you know that, so we have theorem in elementary number theory. So we can if you have two linear congruent equations, how to find out solution, right? So if you have two equations, two linear congruent equations, if you have three linear congruent equations, if you have four linear congruent equations, you need to convert into single equation, right? Single linear congruent equation to get the solution, right? How to convert into single linear congruent equation? So by using Chinese remainder theorem. Already you know that what is Chinese remainder theorem. So please concentrate on Chinese remainder theorem. So it is also very important. So to find general solution for linear congruent equations, system of linear congruent equations, right? How to find out general solution for linear congruent equations, right? So if it is given x is congruent to a modulo m, x is congruent to b modulo n, how to find out solution for these congruence equations, right? Just find out the GCD of Mn. So GCD of Mn is 1. So then you can go with Chinese remainder theorem to get the solution, right? Okay. So but m and n. So for example, x is congruent to a modulo m, x is congruent to b modulo n, mn or not, GCD of mn is not equal to 1. So then how to find out solution? Then how to find out solution? It is also very important, right? So just converting into prime factors for m and for n, so you can able to write down, so you can able to write down the single linear congruent equation into simultaneous equations, right? You can able to write down the single linear congruent equations into simultaneous equation by writing m and n are the prime factors, right? Okay, so this is another concept. So in congruences, right? So you can find out solutions based on the topic, right? So next, so we have the topics. So Fermat's theorem, Wilson's theorem, Euler phi function, right? Euler function, what is Euler function? Number of generators. So you can find out, right? So in these concepts we have find out the number of divisors. So finding number of divisors for n. So finding sum of the divisors. You can find out sum of the kth power of divisors. Okay. So by using the concept of fundamental theorem of arithmetic, so you can use this fundamental theorem of arithmetic. You can find out number of divisors. You can find out sum of divisors. You can find out sum of kth power of divisors. So we have many uses by using the fundamental theorem of arithmetic, right? So and also, so you using Euler pi function, it is also very important. Finding number of generators, okay? So it is very important. So by using Euler pi function, right? Number of primitive roots also included, okay? So by using Euler pi function, right? So these are the topics included in elementary number series. So each and every topic is important. Each and every topic is having the equal weightage, right? So these are the topics in elementary number theory. So next I'll go with the group theory. So group theory having the topics, the definition of groups. So if you know the definition of the group, so we should know what are the examples of group, right? What are the examples? It is satisfying group condition, right? You should know. So you should know what are the properties, right? What are the properties on group? Okay. So subgroups. Next is subgroups. Okay. So some theorem statements. Okay. So here we don't need any proofs, right? So at least you have to remember the theorem statements. Okay. Property statements. So just you need to remember all these things. Here we no need to prove all these things, right? So just you have to remember these statements, right? So next, what is the normal subgroups? What are the concepts in normal subgroups? So we have many concepts in normal subgroups, right? So quotient group, homomorphism, isomorphisms, right? So permutations group, cyclic groups, so Cayley's theorem, Syllobu's theorem, their applications, right? So these are the topics included in group theory. Each and every topic is very important. Each and every topic having the same weightage, okay? So please read carefully. Group theory also. So coming to the ring theory, so we have the topics, definition of ring. What is the definition of ring? The properties on what is definition, properties on definition, examples on definition, which number system is satisfying the ring property, right? So ring theory definition. So you are all aware of these things, right? So what is integral domain? What is field? So what is the relation between field and domain? Integral domain. So okay. So you please carefully read all these things. So it is very important concept, integral domain and field. So please read field, what is integral domain, what are the number systems satisfy field, what is the number system satisfy integral domain. So if integral domain, then it is field or not. If field is, if we satisfy the field, then it is integral domain or not. So we have many concepts here. So please read all these things. Okay, so what is subring? Define subring. So based on that we have many properties. So please carefully, so please follow the properties and theorems in subrings, right? So next is ideals, quotient rings, so homomorphisms, prime ideals. So prime ideals, maximum ideals. Defining prime ideal, maximum ideal is very important. So we'll get questions from prime ideals and maximum ideals, right? So please read all these all these properties and all these theorem statements, all the conditions on prime ideals and maximum ideals, right? And next is polynomial rings. So next topic is irreducibility of polynomial. Irreducibility of polynomial, Euclidean domains and principal ideal domains. So these are the very important concepts. So maybe you can get questions from these topics also, right? So polynomial rings, irreducibility, so Euclidean domains and principal domain, right? So you can get these topics also, you can get questions, you can expect questions, right? So totally these are the 3 topics comes under modern abstract algebra. So I can give the weightage of these 3 topics 30 to 35 questions, right? 30 to 35 questions, 30 to 35 questions, nothing but you can get more than 60 marks, right? The first we have seen real analysis. So my metric space is also included in real analysis. I am giving the weightage 25 to 30 questions, right? So if you are thorough in that topic, so you can get 50 plus marks, right? 50 plus marks. Here you can get 60 plus marks. You can get 60 plus marks if you are thorough in these 3 topics, right? That is previously 2 topics are comes under real analysis. These 3 topics are comes under modern abstract algebra, right? So I'll go with another topic. So we have a theory of matrices, vector spaces. First you have to first go through the matrices. First you have to go through the theory of matrices, later you can go vector spaces, right? So this is order. Don't read vector spaces directly. First you should go through the matrices. Once if you finish the matrices, then you go through the vector spaces, right? So because the matrices concept is very important in vector spaces. The matrices topic is the concepts of matrices are very important in vector spaces, right? To do the problems in vector spaces. So that first you go through the theory of matrices. Theory of matrices, right? Actually, so the linear transformations, rank, nullity, change of basis, so matrix of linear transformation, these all comes under vector spaces only, right? Actually linear transformations, rank, nullity theorem, change of basis, matrix of a linear transformations, these are the topics comes under vector spaces only, right? But here it is given in this topic, but so these are the topics included in vector spaces, right? So theory of matrices and vector spaces, it is called as linear algebra, comes under linear algebra, right? These are the topics comes under linear algebra, right? So first you go through the matrices, later you go through the vector spaces, right? So matrices topics included what is singular matrix, what is non-singular matrix. So we have many definitions in matrices. So I think you are very familiar with definitions in matrices. So no need to explain again, right? So what is the inverse of a matrix? How to find out inverse of a matrix? And what is rank? How to find out rank, right? So we have many properties on rank, right? So you should be right. What is consistent? What is inconsistent? What is homogeneous system? What is non-homogeneous system? How to find out solution for homogeneous system? How to find out solution for non-homogeneous system? Okay, so based on rank. So you have to learn all these topics, right? So once if you are very good in matrices, then it is easy for vector space. It is easy for you in vector spaces, right? Because if you thorough in matrices, it is easy. Vector spaces is easy because this vector space is maximum most of times we'll use matrices concept, right? So please carefully in matrices also, right? So we have another topic, eigenvalues, eigenvectors, how to find out eigenvalues, how to find out eigenvectors. So we have many properties based on eigenvalues, eigenvectors. Please read all these things, right? please read all these, all the properties, each and every theorem statement, each and every property is very important, right? Here we are not proving, in the jail exam we are not proving the statements, right, theorem statements, right? At least you should remember property or theorem statements, right? Then you can able to do the question, right, do the answer, right, in the exam. So we have linear transformation. So it is also, see here, eigenvectors of a matrix of a linear transformation, it is also comes under vector spaces only, right? So linear transformation is, it is nothing but vector spaces only, right? So next, Cayley-Hamilton theorem. So what is the Cayley-Hamilton theorem? What is the use of Cayley-Hamilton theorem, right? So what is the main purpose we are using the Cayley-Hamilton theorems? The application of Cayley-Hamilton theorem. So that is what we are discussing, right? So please read all these things. So we have topics, quadratic forms. So quadratic forms, first you need to convert into matrix. So whatever the quadratic form will be given, you need to convert into matrix. Then you can use the concept of eigenvalues, eigenvectors, right? Finding eigenvectors. After finding eigenvectors, use the transformations. So we have many transformations, orthogonal transformations, linear transformations, right? So congruent transformations. So we have many transformations, right, to find the solution. At last we'll convert this quadratic form into, so at last we'll convert into some diagonal matrix. So later we'll discuss, we'll talk about what is signature, what is index, what is positive definite, what is semi-definite. So we'll discuss all these things, right, on quadratic forms. Please read all these things. So what is quadratic form? So based on the quadratic forms, how to convert into matrices, and after that how to find out the solutions. After getting the solutions, so what is index of that problem, what is the signature of that problem, right? So how to define index and signature based on the eigenvalues, right? Based on the eigenvalues, so based on the matrix, diagonal matrix, right? At last we will get some diagonal matrix. We are converting into diagonal matrix by applying some transformation, right? So based on that we can find out what is signature, what is index, so all these things, right? So please read all these things. So it is, I am giving the weightage of vector spaces and theory of matrices, right? For both the topics, these are the topics comes under linear algebra. These two topics are comes under linear algebra. So the linear algebra is very important. The linear algebra is very important. The real analysis also very important, right? So the real analysis, if you are thorough in real analysis, linear algebra, you can get CSR. You can get CSR, right? That is a weightage in CSR JRF. That is the weightage in CSR JRF for these two topics, right? Real analysis and linear algebra. Okay. So but coming to the JL, so it is different, right? Different story here. These are the topics comes under linear algebra. So you can expect 25 to 30 questions. You can expect 25 to 30 questions from these two topics, right? From these two topics. So that is nothing but you can expect more than 50 marks. You can expect more than 50 marks from these two topics, right? So already we have discussed. So real analysis, matrix spaces comes under analysis. So we have we can expect more than 50 marks. In the last slide we have seen elementary number theory, group theory, ring theory. So comes under modern algebra, right? So real analysis you expect more than 50 marks. Modern algebra, okay. So modern algebra you can expect more than 60 marks. 30 to 35 questions, so that more than 60 marks. Here you can get 25 to 30 questions, so more than 50 marks. Totally, so 50 plus 60 plus 50. So almost 160 marks, right? Almost 160 marks covered from these are the topics, right? So next I'll go with the next topic. So complex analysis. So it is also very important topic. So real analysis is different and complex analysis is different, right? So you can expect a complex analysis, at least you can expect 10 to 15 questions. You can expect 10 to 15 questions from complex analysis, right? So if possible you may get 15 to 20 questions also. So it is very important concept, right? So complex analysis you can get 10 to 15 or 10 to 20 questions also we can expect, no problem, right? So because it is very important concept. So we have the topics, algebra of complex numbers, the complex plane, so complex functions and their analyticity, how you have to check the analytic conditions, right, based on the differentiability. If it is continuity differentiability, then only it is analytic functions, right? So you have to thorough in continuity differentiability before going through the analyticity, before defining analyticity, right? So you have to thorough in what is continuity, what is differentiability, okay, so of functions, right? So CR equations, so based on CR equations you may get questions, right? So please CR equations in Cartesian and as well as the polar forms, right? So you may get questions from polar forms also, right? So please remember all these CR equations in Cartesian as well as polar, okay? So next, Mobius transformations. So we have power series, so Taylor series, Lorentz series. So how to express in Taylor series, how to express in Lorentz series, okay? So these are the power comes under power series. So complex integrations, so we have seen already. So what is Cauchy's theorem, what is Cauchy's theorem, what is Cauchy's integral formula, okay? So Cauchy's theorem, Cauchy's integral formula is very important in complex integration to find the problem solutions, right? So you may get questions from complex integration, okay? So you may questions from Cauchy's based on the Cauchy's theorem also, right? So you know that based on the Cauchy's theorem, so directly answer should be 0. So you should be aware of this, right? All these things, right? So you have Lewis theorem, so maximum modulus principle, so Scavar's lemma, so Taylor series, Lorentz series, okay? So calculus of residues, evaluation of integrals. So these are the topics. So included in complex analysis. So it is very important concept. So you can expect 10 to 15 questions from these topics, right? So that is, you can expect 20 to 30 marks. You can expect 20 to 30 marks from this topic, complex analysis, right? So next, I'll go with the problematic portion, right? So these are all comes under problematic portion. So ordinary differential equation and partial differential equation, right? It's comes under differential equations, right? So these two topics are comes under differential equations, right? So it is also very important concept, okay? So you can get at least 25 to 30 questions from the differential equations, right? You can expect 25 to 30 questions. You can expect 25 to 30 questions from these two topics. So ODE, PD is also very, very important, okay, in JL. So you can expect 25 to 30 questions from these two topics. So if you are thorough in these two topics, you can get more than 50 marks. Right? I think so. You people are very familiar in ordinary differential equations and partial differential equation. You can score more, right, here. If you are weak some section, if you are weak in some section, you can score in other sections, right? So I think so. Some people are lack in some theory concepts, right? But some people will good in problematic portion, right? So that you can I think so. The people, all the people are have the good aware of these topics, right? So different ordinary differential equation and partial differential equations, right? So you go through well. So but it will take, so in the examinations, so when we are solving the problems, it may take some times, right? But so these are the topics you can score more. These are the topics you can score more marks, right? So please go through all the topics. So what is the definition of ordinary differential equation? What is the order? What is the degree? What is the linear? What is non-linear? So defining linear, defining non-linear. So based on first order, first degree, so we have solutions. So how to find out solutions for first order, first degree equations? Already we have many methods: variable separable, homogeneous, non-homogeneous, exact differential equation, non-exact differential equations, linear equations, Bernoulli equations. So we have many equations, right? Many methods to solve first order, first degree equations, right? So please go through the all, right? And also we need to you need to read applications. What are the applications of first order, first degree, right? So Newton's law of cooling, natural growth, decay. So these are the examples, right? And also orthogonal trajectories. So this is also application of first order, first degree ordinary differential equations, right? So please go through all the concepts, right? Don't leave each and every don't leave any topic, right? You go through all the topics in this differential equations, right? So next, first order is over. Next, higher order, first order, higher degree. So actually, so higher degree is nothing but it is non-linear equations, right? We don't have any methods in nonlinear problems, right? Bernoulli equation, it is a nonlinear equation only. First we need to convert into linear equation to get the solution, right? So next, so equation solvable p x y. So these are the these are the methods: solving p, solving x, solving y. So these are the methods to solve nonlinear PD, right? If degree is more than 1, okay, if degree is more than 1, so we have the methods to find the solutions. So using solvable for p, solvable for x, solvable for y. Already you know that, right? So if it is first order, first degree, so we have methods up to Bernoulli, right? And applications, orthogonal trajectories, and natural growth, decay, Newton's law of cooling, right? Comes under first order, first degree. If you go through the higher degree, first order with higher degree, so you can you have methods solvable phi for p, x, y. So these are the methods. So what is the Claret's equation? Already you are very familiar with Claret's equation and the solution of Claret's equation. And what is the singular solution, right? What is the singular solution when the differential equation given? So what is the singular solution for that? So what is the linear differential equation with constant coefficients and variable coefficients? So higher order differential equations. Coming to the higher order differential equations here. So linear differential equations with higher order, right? Degree is 1, but order is more than 1, right? Maybe 1 or more than 1. Higher order linear differential equations, right? So you have methods to find out what is complementary function, how to find out complementary function, how to find out particular integral, right? So you have cases the right side the function is very already you know that. So if the right side is if you denote it as some q of x, it may be exponential function, it may be a function of x, okay, it may be a function of x, it is nothing but x power k. So k is any integer, right? Any positive integer, and q of x is sin x or cos ax, sin ax plus b or cos ax plus b. So you have methods. So x into sin ax plus b, x power k into sin ax plus b, or e power x into sin ax plus b, x into e power x into sin ax plus b. I am talking about right side, right? If it is homogeneous equation, you will get only complementary function. That complementary function is called general solution of the given linear differential equation, right? Okay, but if you have the non-homogeneous equation, that is nothing but, so right side f of d into y equal to some q of x, f of d into y equal to 0, that is homogeneous equation. F of d into y equal to q of x, it is non-homogeneous equation, right? So if it is homogeneous equation, the complementary function itself is the general solution of that equation, okay? If right side is not equal to 0, then you have to define particular integral, then you have to go through the particular integral, right, to find the general solution. At last you have to find out the general solution by taking complementary function as well as particular integral. The addition of complementary function and particular integral gives the general solution of the linear differential equation, right? So for that you have some different methods. Based on right side q of x, right? So you go through all the topics, and linear differential equation with constant coefficients. After that we have variable coefficients also, right? So for variable coefficients, first you need to convert into constant coefficients, right? First variable coefficients are converting into constant coefficients by applying some methods. So you know that already, you have very familiar, I think. So Cauchy's method, legendary method. So these are the two topics. So these are the two methods you can convert the variable coefficients into constant coefficients. So then apply the same concept, whatever the concept you are using for linear differential equation with constant coefficient, the same concept used for this also, you can get the solution, right? So these are the topics in linear differential equation and variation of parameters. So this is very important. So for variation of parameter, right side function, any function, right side the function will be given in terms of tan, secant, cot, cosecant, or any function, right? Logarithm function, okay? So any function it will be given, right? Actually, so to find out particular integral for linear differential equations, so we have some particular cases, right? So one is right side q of x must be equal to e power ax, or q of x is equal to x power k, or q of x equal to sin of ax plus b, or q of x equal to cos of ax plus b. And the next is x into v. V is nothing but either e power ax or sin of ax plus b. And the next topic is x into e power ax into sin of ax plus b. So these are the methods we have to find out particular integral, right? But coming to the variation of parameters, so the right side function any function, but order should be 2. Here in a variation of parameters, so the differential equation having the order must be 2 only, right? Because he can get 2 independent solutions here. Based on the 2 independent solutions, you can apply the variation of parameters method, right, to find the general solution. Okay, so please remember all these things. The use of variation of parameters is very important, okay, because the right side any function it will be given, you can find out solution for the differential equation by using variation of parameters, but it should be order should be 2, right? Order of the differential equation should be 2 only, right? So next, coming to the partial differential equations, so it is also very important. So the weightage of these 2 topics, I am giving 25 to 30 questions, right? You may get 10 questions from here, you may get 15 questions from here also, right? But because PD is very important, right? Coming to the importance of OD and PD, you may get more questions from PD. You may get more questions from PD, right? So than OD. So if you get 10 questions here, you may get 15 questions from here. So that is the weightage of PD, right? So PD also same. So formation of PD. So for how to formation of PD, so by eliminating constant, by eliminating functions, I think you are very familiar. So how to formatting the PD, right? So by eliminating arbitrary constant, by eliminating functions, arbitrary functions, right? So and you have Lagrange's equation. Already you know that. So in the Lagrange's equations also you can find out Lagrange's equation, nothing but, so it is in the form of P into P, capital P into small p plus capital Q into small q equal to R. It is quasi-linear PD. It is quasi-linear PD, capital P of xyz into small p plus capital Q into Q of xyz equal to R of xyz. It is quasi-linear PD. So how to solve quasi-linear PD? By using Lagrange's method. So you have 4 models in Lagrange's methods. So you have multiplier method, you have grouping method. So we have different methods to find out solution in Lagrange's equation by taking Lagrange's auxiliary equation, right? So you have another method, Charpit's method. It is non-linear first order PD, right? It is non-linear first order PD. For non-linear first order PD, so you can find out solution by using Charpit's method, right? So and also you have some methods to find out non-linear PD of first order. So if it is in the form of, if they are in the standard forms, f of p comma q equal to 0, f of p q z equal to 0. So next, Claret's equation in PD, Claret's equation. Next, so f1 of xp equal to f2 of yq. So these are the 4 different models in first order non-linear PD. So we have general methods. So that is general method is Charpit's method, right? So to find out solution for non-linear first order PD. So next, so we have Cauchy problem. So how to find out solution for Cauchy problem? Such that whatever the concept we are using for Lagrange's, the same concept we are using for Cauchy problem also to find the solution. But in the Cauchy problem, so you can get solutions, unique solution or infinite solution, no solution, right? So you need to careful on Cauchy problem. So the questions will be asked like this, right? So problem will be given. So apply the Cauchy method. So how many solutions it will get, right? So you may get unique solution or infinite solution. You may get no solution for no solution also, right? Based on the problem, different problems, right? So Cauchy problem also. So the same concept, whatever the concept you are using for Lagrange, the same concept used for Cauchy problem to find out the solution, because here we will use the Lagrange's auxiliary equation. By writing Lagrange's auxiliary equation only we can find out solution. Here also the same concept we will use in the Cauchy problem also, right? So next, classification of second order PD. So classification of second order PD. So already you are very familiar with classifications. So the equation should be in the second order of PD. So then later you have to define hyperbolic condition, parabolic, elliptic, right? So which equation is parabolic, which equation is hyperbolic, which equation is elliptic, all these are the classifications, right? So b square minus 4ac is greater than 0, hyperbolic b square minus 4ac equal to 0, parabolic b square minus 4ac less than 0, so it is elliptic. So all these are comes under classification of second order PD, right? Next, general solution of higher order PDs with constant coefficients. Here general solution of higher order PD with constant coefficients, nothing but the same concept actually. So here higher order linear differential equation, what we are doing here, the complementary function we are finding, particular integral finding. So just we are adding complementary, particular integral, it will give us a general solution of given linear differential equation for in the ODE, right? The same concept here also. So we need to find out the complementary function as well as particular integral. So to find out higher order PDE solution, right, with constant coefficient. And also actually, so we have variable coefficients also is there in PDE, but it is not included in the syllabus here. So we have only constant coefficients, right? So these are the important, these are the topics in partial differential equations, right? So these two are very important. These two are very important. So please go through the weightage. So you can get 25 to 30 questions from these two topics. Okay, you can score more here, right? So comparatively, theory topics you can score more here, right? Okay, so because you are, I think you people are very familiar on these two topics, right? So please carefully go through these two topics, right? A last topic, so solid geometry. Okay, so it is comes under the geometry. So it is the only single topic comes under the geometry. So you have the topics, the plane, what is line, what is plane. So sphere, cones, cylinders, concaves. So you have these are the simple topics. So these are the topics comes under solid geometry. So only few topics are there included in solid geometry. So you can expect 10 questions. You can expect 10 questions from the solid geometry also, because so each and every topic have the individual weightage. So we have 11 topics. We have 11 topics in JL exam. So it is also included. So you can get 10 questions, right? You can get 10 questions from solid geometry. So actually, so we are seeing the topics are very less, right? So it is showing that the topics are very less, right? But so we have the many topics, okay, many subtopics here. We have many topics for these topics, right? So that so you can expect 10 questions, at least 10 questions from here. So that more than 20 marks from this topic, right? From this topic, right? So please carefully so read all these topics. Each and every topic is very important. So if you thorough in mathematics, right? If you thorough in subject, if you thorough in content, then only it is easy for you, right? Because so you have 150 questions. So you have 150 questions, 300 marks. So if you score more in subject, so in GS if you score even average also, you may have chance to get the job, right? So if you are thorough in subject, so it is easy for you, right? When you are doing in general science, right? So it is easy for you. So of course GS also you can score, no problem. But if you are thorough in subjects, so people are almost everybody will do the problems. Everybody will do better in subject, right? Most of them will do better in subject, right? Not in GS. Of course, some people are preparing GS from past 5 years or 10 years. They can do, no problem. But once if you do the subject better than GS, then you may have the chance to get the job, right? So at least you may score more than 260 marks, in the subject. Out of 300, you should get more than 260, right? So that is nothing but at least you should do correct 130 questions. Then only you will get 260, right? So there is no negative marking here. So please carefully read the question, answer the question, right? So each and every topic is very important. Already I given weightage of the individual topics, right? So real analysis, modern algebra, linear algebra, complex analysis, differential equations, and solid geometry. So these are the topics so we have in the JL exam, right? So it is the same syllabus for Gurukula as well as general JL. So but what is the difference? There is a negative marking in Gurukula. Here there is no negative marking. So marks also different. 150 questions, 2 marks each one. So totally 300 marks in general JL. So whereas in Gurukula JL, so we have in Gurukula JL we have 100 questions, 100 marks. There is a negative marking, right? In general JL we don't have any negative marking. 150 questions, 2 marks each, 300 marks subject, right? So 300 marks subject, 150 marks general science. Totally it has 450 marks, right? Already you know that, right? So go through the subject carefully, so you can success, right? Thank you.
తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని. టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు, 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని అండ్ సరిత. టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత. మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 డిఎస్సి ఎస్జిటిలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్. స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్లో టీజీటీ మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, టీజీటీ బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, టీజీటీ సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, టీజీటీ సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, టీజీటీ తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, టీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, పీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, పీజీటీ ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 డిఎస్సి గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. డిఎస్సి గురుకుల టీచర్స్ మరియు గ్రూప్స్ ఎస్ఐ కానిస్టేబుల్స్ కోచింగ్ కొరకు డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422, 8885555202, 88585900, 8008954440, 8008954448, 8520844463.